Hello and welcome to this session on a closer look at Azure Arc. My name is Janakiram MSV. I am a Microsoft MVP and a regional director based out of Hyderabad, India. It's my pleasure to be a part of the Microsoft Developer Conference 2020. So this session is all about Azure Arc, one of the most recent Microsoft technologies that is related to hybrid and multi-cloud environments. So I'm going to start off with an overview of Azure Arc, followed by a discussion on the essential building blocks of Azure Arc, including Azure Arc for servers, Azure Arc enabled for Kubernetes, and Azure Data Services. I also have a couple of demos to drive the point across to show you how to register external servers with Azure Arc, and also how do you bring external Kubernetes clusters into Azure Arc environment. So let's get started. When we look at the current state of enterprise IT, it's overwhelming. There are thousands of applications running in a variety of environments. They run on virtual machines, they run on Kubernetes clusters, they are written in a variety of languages, some of them are legacy monolithic applications, some of them are very modern microservices based applications. There are even client server applications and even non-Windows applications that are running in an enterprise. And recently, in the last decade, we have seen how the infrastructure has gone beyond the data center to environments like public cloud, edge computing, and third-party environment like hosters, co-location providers, and so on. Now, cloud has become mainstream, and apart from running the infrastructure on premises within the data center, colo, and a private cloud, customers are also investing in multiple cloud platforms such as Azure, AWS, and Google Cloud. Now imagine if you are a part of the enterprise IT. How do you take control of this overwhelming, sprawling application and infrastructure landscape? On one side, we have a variety of line of business applications and third-party applications that are deployed in a variety of environments. And then on the other side, you have infrastructure that is spanning your on-prem data center to a colo, to a hoster, and to public cloud environments. It's very, very complex to manage this landscape of applications and infrastructure. And Microsoft has been looking at addressing this issue through a couple of initiatives. Particularly if you look at Microsoft's hybrid strategy. On one side, we have Azure Stack, which is a family of products that basically address how to bring public cloud-like capabilities all the way to the enterprise data center and the edge. The Azure Stack Hub, the Azure Stack Edge, and Azure Stack Hyperconverged infrastructure are addressing this use case where customers can run cloud capable services and cloud enabled services within their environment. Going beyond the data center in highly constrained environments like large trucks, ships, vessels, aircrafts, and so on, Microsoft has Azure IoT, which is going to take some of the capabilities of Azure, particularly the Azure IoT Hub, Azure Stream Analytics, and the SQL Server for Edge, and run them very close to the origin of data. So Azure IoT Edge is going to address the scenario of bringing compute, storage, and analytics very close to the devices and the sensors that need to actually process the data and even run machine learning models, perform inference, and quickly do complex event processing, all of that very close to staying at the origin of data. So that is typically addressing or aligned with the industrial IoT scenario. On the next level, if the customer has an environment like a data center and he can afford to run slightly capable high-end environments, high-end appliances, they can go for Azure Stack Edge, the hyperconverged infrastructure, or even go for Azure Stack Hub and deploy some of the products from the Azure Stack family. Now, in between Azure IoT Edge, which is aligned with devices and industrial scenarios, and Azure Stack, which is running Azure services on-prem, there is something called Azure Arc, which is the focus of today's session. And this is essentially designed to enable customers to bring their infrastructure running on physical machines, virtual machines, and Kubernetes clusters into the fold of Azure. So apart from running applications in the public cloud or running them in the private cloud or in a hybrid environment through Azure Stack, or even a miniature version of them at Azure Stack Edge, now customers can bring their existing servers, Kubernetes clusters, into the context of Azure. So this cuts across the entire spectrum, all the way from devices to the public cloud and everything in between. So Azure Arc is a very unique offering available in the industry. I think Microsoft is the only company that has announced, launched, and delivered on a vision of enabling true hybrid and multi-cloud platform through Azure Arc. So let's understand this better. Now, there are certain capabilities that Azure Arc brings to customers. So let's understand them in more detail. So first of all, Azure Arc enables customers to bring existing servers running Windows and Linux, either in physical bare metal servers or in virtual machines, and register them with Azure Arc. That gives them a lot of flexibility and control, treating them on par and at par with cloud servers, applying the same set of policies, configuration, and auditing and managing the entire infrastructure irrespective of where they run is a tremendous advantage. And then it doesn't differentiate between virtual machines and Kubernetes clusters. Just like customers can onboard VMs and physical servers, they can also onboard Kubernetes clusters to Azure Arc. And once you have a Kubernetes cluster registered with Arc, you can also run Azure Data services. This is still under private preview, but what it enables when it becomes available publicly is the capability of running Azure SQL and Postgres Hyperscale in any environment of your choice. If you are running an Azure Arc enabled Kubernetes cluster in your data center, you can actually run a managed SQL and managed Postgres within that environment. If you have a cluster running in environments like Amazon or Google, you can take Azure Data Services even to other cloud environments. More on this later when I touch upon the Azure Data Services building block of Arc. But essentially, Azure Arc is a set of technologies that extends Azure management and brings managed services of Azure to on-prem, multi-cloud, and edge. And this is a very compelling value proposition for enterprises, because unlike the other offerings that are available in the market that only address the container-based platforms and container-based Kubernetes-based environments, Arc goes beyond Kubernetes and also enables a true hybrid scenario of VMs and Kubernetes clusters. And customers can bring all of them into the context of Azure Arc. And this is very, very compelling and very powerful differentiating factor for Microsoft. Now, as I mentioned earlier, there are three specific use cases that Azure Arc addresses. The first one is organizing and governing multiple disparate heterogeneous environments. If you have been in the industry for a long time, you know that there was a concept, there was a terminology used by enterprise IT, and that was called VM sprawl. So when hypervisors became popular, whether it was Hyper-V or VMware's vSphere, customers ended up launching tens and thousands of VMs every time they needed compute, using either System Center or VMware vCenter. And very soon, there were multiple virtual machines that were running all over the organization with absolutely no control. And that resulted in what was called as VM sprawl. Of course, eventually both Microsoft and VMware shipped a lot of tools and mechanisms to bring the VM sprawl to control and make it more manageable. Now fast forward to 2020, today we are experiencing what we call as the cluster sprawl. Now Kubernetes is a very powerful environment. It's a platform that brings up lot many use cases and lot many opportunities for developers, operators and SREs. And it also brings in a very isolated environment when you're running a workload in a specific cluster. So because it has become so much easier for customers to launch a cluster either in Azure or Google or AWS or even on-prem using tools like KubeSpray and kops to target the cloud, customers are launching Kubernetes clusters very often. And each cluster is running an application. So instead of creating namespaces or instead of partitioning applications within a cluster, many developers and operators find it easy and secure to spin up a cluster and run a workload on it. And this is responsible for the cluster sprawl. Now what Azure Arc does is to handle both the VM sprawl and the cluster sprawl. So VM sprawl is running multiple virtual machines in your data center, in multiple public clouds, and in multiple other virtualized environments. And similarly, cluster sprawl is running Kubernetes clusters everywhere. Now the problem with this approach is you don't have a single unified view. There is no single pane of glass to control the resources, whether they are VMs or clusters. And there is no way for you to impose and enforce certain policies that are applicable to any cluster running anywhere. And that is a big challenge which is addressed by Azure Arc. So with Azure Arc, customers can organize and govern resources, whether they are VMs or Kubernetes clusters, across multiple environments. And at the core of Azure Arc, there is Kubernetes. And because Kubernetes provides a very reliable infrastructure layer, Microsoft is able to bring the data services and workloads into Kubernetes. It also leverages the Kubernetes environment to bring in a very unified view of the application layer, because irrespective of where Kubernetes is running, whether it is Amazon EKS or Google GKE or AKS or a DIY cluster running on-prem, there is something common across all these Kubernetes clusters. And that is the promise of Kubernetes, a very consistent, very conformant API, irrespective of which flavor of Kubernetes you are running. So by leveraging that, Microsoft can manage Kubernetes clusters running anywhere, and it can also tap into the primitives of Kubernetes to deliver a very highly available and fault tolerant and rock solid data services and managed services on top of Kubernetes. And that enables customers to run some of the managed services like Azure SQL and Postgres Hyperscale in Kubernetes clusters managed by Azure Arc. So to summarize, there are three core capabilities or use cases addressed by Azure Arc. The first one is organize and govern resources, compute resources across environments. Leverage Kubernetes for managing scalable workloads, both stateless and stateful. And finally, bring Azure managed services like data services to Azure Arc environments running Kubernetes. Now, I have seen the evolution of Azure in the last decade. In fact, exactly 10 years ago, Microsoft made Azure generally available. And from there to where we are, Azure has come a long way. Now, somewhere in the journey, Microsoft has consciously moved away from the original way of managing Azure resources to a more sophisticated and extensible mechanism called the Azure Resource Manager. Now, in this slide, you actually see that the Azure Resource Manager is almost like the entry point to Azure. Customers interact with Azure Resource Manager and it is going to orchestrate and manage the life cycle of various resources that are running in the context of Azure. And the beauty of Azure Resource Manager is it's extremely consistent whether you are running it in the public cloud or you are actually running Azure Stack in a private or hybrid environment. You still get to use the same portal experience, same SDK, same CLI, and the entire ecosystem that's built around Azure can leverage it irrespective of whether you're targeting the public cloud or the hybrid cloud based on Azure Stack. So Azure Resource Manager is the orchestrator that is managing the life cycle of a variety of resources, including Azure VMs, AKS clusters, Cosmos DB, Azure SQL. Almost every resource is orchestrated and managed via Azure Resource Manager. In fact, ARM templates are the declarative mechanism to submit a provisioning request to Azure Resource Manager. So the ARM templates act as an input, and that input translates to one of the managed services within the context of Azure. Now, there are a lot of benefits of using a fabric, a centralized orchestrator like Azure Resource Manager. There is one and only one entry point to the entire cloud environment, whether it is public cloud or hybrid cloud, and then it provides very granular approach of performing authentication and authorization and RBAC. It also gives you centralized capabilities like monitoring, the DevOps capabilities, auditing, applying policies, and ensuring compliance and all of that. Now, what Microsoft has done with Azure Arc is to basically extend the capabilities and power of ARM, Azure Resource Manager, not just to the managed services of Azure, but even to resources that are running outside of Azure. So here you notice that Azure Arc acts as the conduit, as an intermediary layer between non-Azure resources like your Windows and Linux machines that are running outside of Azure, Kubernetes clusters pretty much running anywhere, and some of the managed services like Azure Data Services. Now, these are not originally created or provisioned or managed by ARM. They are completely external, and they are not visible originally in the Azure context. They don't operate in the realm of ARM. But thanks to Azure Arc, it becomes the key conduit, the intermediary, the layer between the ARM that is running in the public cloud and the resources that are deployed pretty much everywhere. And this is going to expose third-party Kubernetes clusters and VMs to ARM. Now, what does this translate to? Well, if you enjoy the power of ARM by creating ARM templates and by performing auditing, policy, and ensuring compliance, and programmatically managing the resources, now you can actually do all of that with the Azure Arc resources registered as ARM resources. So you can actually do for each VM and do a specific audit trial, or you perform a compliance check. Now, when you run a for each on Azure VMs, even the external VMs that are registered through Azure Arc show up in the same resource group. And that gives you a lot of power to make sure that you're not only taking care and taking control of the resources deployed within Azure, but even those that are running outside of Azure. So think of Azure Arc as the intermediary, the conduit, the agent between ARM and external resources. Now, let's understand this in a customer context. Now, imagine there is a large financial institution which is experiencing both VM sprawl and cluster sprawl, right? But let's focus more on the VMs and servers. So they have their infrastructure spanning their data centers, third-party hosters, colo providers, and public cloud. And DevOps and the internal admins don't understand and don't have a handle on how many servers are actually running in the context of this organization and how to manage them. And it is becoming overwhelming, and a lot of infrastructure resources like VMs and bare metal physical machines are not compliant. They have a lot of gaps that need to be plugged. And the business very clearly asks them to manage the diverse mix of bare metal Windows and Linux servers running on physical bare metal servers as well as virtual machines, and gain visibility into all these servers and get a good understanding of the locations, the operating system, the context under which these infrastructure resources are running, and then apply IT policies and ensure that you are able to scale it from on-prem to pretty much to the cloud. Enable application owners to apply and audit to meet their own requirements. Now, every business unit and every application development team may have their own set of policies and compliance requirements that they need to enforce. That is a very important business requirement. And finally, measure and remediate compliance at scale and get down to the detail, even to an extent of individual workload and server. Now, today, it's very, very complex to manage this disparate, heterogeneous, fragmented infrastructure running all over. There is heterogeneity everywhere, in the locations, in the type of machines, in the operating system, the workload, and getting a single view, a unified view across this is a tough task. It's a huge challenge for IT. Now, what happens if the customer uses Azure Arc to manage this disparate heterogeneous environment? Well, as you actually notice, Azure Arc is going to bring everything that is running in non-Azure cloud environments. It doesn't matter whether it is GCP or AWS or Alibaba or Tencent or Huawei cloud. It doesn't matter. You can still bring those resources to Azure, and at the same time, you can also bring on-prem resources that are running in your data center and hosted environments and colo providers into the context of Azure. And because now all these resources are becoming visible in single pane of glass, which is Azure Portal, you can start to take control. You can perform audit trail to see if there is any machine that is experiencing a drift and deviating from the state it's supposed to be in, and then perform compliance checks, and finally ensure that you are actually remediating and applying those policies to ensure that every server that is registered with Azure Arc has exactly the same set of policies and compliance checks that are enforced all the time. Now, this is a huge benefit to enterprise IT, bringing in bare metal servers, virtual machines, cloud VMs, all of them into one fold and managing them from a central location. Now, I want to show you a demo of Azure Arc for servers. So how do you bring servers running in disparate environments, and how do you manage them from Azure Portal? So time for a quick demo of Azure Arc for servers. All right, so we are at the very first demo where I want to show you Azure Arc for servers in action. So imagine an environment, a scenario where you have servers running in different environments. Let me show you where my VMs are running. So here is Amazon EC2. So I have a VM running within EC2 called app EC201, and this is currently running in Mumbai region of AWS. Now, this is one of the VMs where I run a workload. Similarly, I have a VM running in GCP, Google Cloud Platform, and this is running in Singapore region. Now, apart from these two, I also have an on-prem VMware environment and you notice I'm running two VMs in the context of vSphere. Now all of them are running a flavor of Linux, and my goal is to ensure that all the VMs, irrespective of where they are running, are visible at Azure context, number one. Number two, perform an audit trail and see how compliant they are, number two. And then number three, remediate this compliance gaps and make sure that all of them are 100% compliant with my policies. So how do we go about onboarding these servers or VMs running in very, very diverse and heterogeneous environments? So let me show you this. Now I'll switch to the Azure portal, and I have a resource group called Arc VM Demo. And you notice that there are VMs here. The first one is a native Azure VM. So it actually shows up as virtual machine that is a part of Azure VM's environment. So this is a native VM running within Azure. But if you notice, there is also app EC201, GCE01 and VM01. Now they represent the VMs running in Amazon EC2, Google Compute Engine and VMware. And if you look at the type, the Azure Resource Manager type, they are Azure Arc machines. That means only this VM has been provisioned and launched via the Azure control plane, but the life cycle of these VMs are managed outside of Azure, but I was able to still register them. So that's how we actually got these VMs showing up in the Azure portal. But how do we onboard a VM? Well, it's pretty straightforward. Now I'm going to click Add and type Arc. So when you actually type Arc, you notice that there is something called Azure Arc for Servers. So Azure Arc for Servers, which is still in preview, will walk you through a wizard, a typical Azure portal interface, to quickly onboard a server. So let's click on Create. Now when you click on Create, there are two choices: add machines using interactive script or add machines at scale. Now if you want to really do a bulk registration, you can use add machines at scale, but if you want to do it for a handful of machines, you can generate script that you can run in every machine. So let's go for generate script, and my goal is pretty simple. So here I have two VMs, so VM01 and VM02. VM01 was already visible in Azure, but VM02 was not. So let's actually onboard this VM running on vSphere into Azure Arc. So I click on generate script. So I choose my subscription, then the resource group. So this is the Arc VM demo resource group that has a bunch of VMs. The region, so let's actually use Southeast Asia because that's where my resource group is created. And then choose the operating system, Windows or Linux. This is because based on the OS, Azure Arc will generate a script that can be run in the target VM. So we choose Linux, and if you are behind a firewall and a proxy, you can also mention the proxy server URL, because this is to make the agent that is being pushed in the VM to actually communicate. So make sure that it is able to establish a connection with Azure Resource Manager. So we don't need to provide proxy because I have outbound internet access and my VMs are not behind a firewall or a proxy. And then you can provide tags. For example, let's choose the cloud as VMware. So that is one of the tags that I want to add. And then in the next step, you basically review, and if you want, you can download the script, but this is it. Basically, a couple of commands. You download a script, a bash script, and then you execute the script. And then finally, you register the agent that is going to be run inside the target VM with certain parameters. For example, the resource group, the tenant ID, the location, and the subscription ID, and whatever tags, the key value pairs that you actually add. Now, let's actually switch to the command prompt. So I am in the terminal and I'm going to SSH into my app VM02 running on vSphere. So I will SSH and then I'm going to quickly become root user. This will help me run the script. So to save time, I have already run the existing commands. For example, I have already downloaded the script. I have installed the script. This is going to basically run a bunch of apt-get install commands. Finally, I have to just run this single command. So the agent connect followed by the parameters that we have seen earlier. Now I'm going to run this. The moment I run the command, it actually prompts me to go to device login page and enter this token. This is how you authenticate Azure CLI. So it's not very different. So we copy this, come back to the authentication page, click next and choose our account, and very soon this is going to show that the onboarding has been complete. So once the onboarding process is complete, we can go back to the portal and do a refresh, and our app VM02, which is the host name of this Linux VM running in vSphere, it shows up in the Azure portal under the type, the Azure Arc. There we go. So now successfully onboarded resource to Azure. And now let's check this. So I'm going to go back to the Azure portal and look at there we go. So app VM02 shows up, indicating that the process has been pretty smooth. Now you notice that there are some tags that are already added. For example, I added cloud VMware, environment is staging, type is demo. These are automatically applied because I actually set up a policy. So let's now switch the context to policy. Now you can assign a lot of policies. A detailed walkthrough is out of the scope of this session, but you can spend some time understand how Azure policy works. Now I actually added a tag that says appended tag for every new VM that is onboarded, or even check if there is a tag available to all existing VMs. So only 33% of the resources are compliant. I can actually see which are those compliant VMs. So these VMs actually have a tag called type demo that I am trying to impose. Now obviously our app 1 and 2, particularly 2 doesn't show up because this is not run yet, but in a few minutes when the next evaluation happens, it is going to find that the most recent VM that is onboarded actually is compliant because it has the tag. Similarly, you can run some of the other policies. For example, I have a policy that I just created, but it is not completely assigned and it's not evaluated yet. But show audit results for Linux VMs that do not have the password file permission set to 0644. Now this is a very important policy. Now I want to make sure that none of the VMs that I own, that my team owns, leave a insecure passwd file in /etc. So I can actually have this as an audit and run it pretty much on every VM that is registered in this resource group. So this is a very, very powerful capability through which you can actually bring not just Azure managed VMs, but also the other VMs that are added via Azure Arc. Now, if you notice, this is the native Azure VM, and then we have Amazon EC2, GCE, and VMware VMs and instances showing up in Azure portal, and you can actually run Azure policy on top of it, and you can manage these VMs from a single pane of glass. Extremely powerful mechanism to control and take charge of VM sprawl. So that concludes the first demo. Now the next part, I'm going to walk you through Azure Arc enabled Kubernetes clusters. All right, so right after the demo, let's understand another customer use case. Now imagine there is a retailer with hundreds of stores and all of them are running Kubernetes clusters. Now, the challenge that IT has with this environment is ensuring that the applications are deployed consistently across all the clusters running in all the stores, and they also have certain predefined policies and RBAC related policies that are actually deployed, and they're extremely consistent across all the 100 stores. Now, there are going to be new stores that are going to get added, and as soon as a new store comes up and a new Kubernetes cluster shows up, it should automatically inherit some of the policies and some of the existing deployments that the other Kubernetes clusters have. And then creating a single pane of glass for monitoring the metrics that are coming from all these clusters to ensure that there is a very insightful observability dashboard that is available to monitor the state of all the clusters, all the workloads running across 100+ locations. And finally, this should allow the regional and the store level IT to monitor and quickly troubleshoot configuration issues. So pretty straightforward. Deploy workloads across all the 100 clusters, make it easy to onboard new clusters, maintain consistent standard compliance and policies across all the clusters, bring centralized observability, and reduce the time it takes to debug issues. So how can this be handled? Well, that is the second promise of Azure Arc, where you can bring external Kubernetes clusters into the fold of Azure Arc. So once customers bring in external clusters into Azure Arc, they can maintain a centralized inventory with a unified view using the portal and the command line. They can perform at-scale deployments of any Kubernetes object, including creating namespaces, creating daemon sets, creating config maps. Anything that needs to be consistent across the cluster can be pushed via the Azure Arc enabled Kubernetes control plane. And this brings in the most modern, most recent methodology of deploying applications called GitOps. I have a live demo of this, stay tuned for that. Finally, bring configuration as code. You version control your artifacts that go along with your code and provide an ability to roll back and roll forward the configuration, not just the code and the deployments. And also make sure that all the clusters have a desired state of configuration maintained. Now, all of those can be achieved by registering a Kubernetes cluster with Azure Arc. Perfect. So let's get to a demo where I'll walk you through how we manage Kubernetes clusters in hybrid and multi-cloud environments. So let me switch to the demo and show you my current environment. So here I have 4 clusters. So the first cluster is running on-prem on a bare metal environment. So this is my on-prem cluster. Then I have a GKE cluster running in Google Cloud Platform. So this is my GKE cluster running in Singapore. Then I have an EKS cluster running in AWS. So this is a very diverse and very heterogeneous environment. One cluster running in bare metal, the other cluster running in Google Cloud, the third cluster is actually running in EC2, that is AWS and EKS. And I also have a local AKS configuration, local as in native. So when you actually look at this, it reports the nodes from the AKS cluster running natively within Azure. So 4 clusters. Now, if there is a single objective of deploying an application from all the into all the 4 clusters from one location, number one. Number two, how do we bring in observability for this workload that we have just deployed from all the 4 clusters? Third thing, how do we avoid the cluster drifting away or deviating from the standard configuration? And finally, how do we ensure that all new clusters inherit the same deployment, same configuration, and same policies? Well, it all begins by registering these servers with Azure Arc. Now let me show you where these are actually running. So here is my EKS cluster. So this is my EKS cluster running the worker nodes in the context of EC2. It is AP South 1, which is Mumbai. This is my GKE environment. This is also running in Mumbai, and it has 3 nodes. You have seen this from the CLI, but I'm showing you the dashboard. So the first step is to basically register these clusters just like the VMs, but register these clusters within Azure Arc. So we simply run a command called az connected K8s, which is connected Kubernetes, and point it to the actual resource group. So in Azure, I have a resource group called Arc Kubernetes Demo, and I point that and give the name of my server, set the context, and as soon as we run this command, the bare metal cluster shows up here. It just takes a few minutes for the agent to get installed. Just like we pushed an agent into the VM, here we push an agent into the Kubernetes cluster. So let me switch to the metal and show you the namespaces. So the moment I install the agent, there is a Azure Arc namespace. So if you inspect that from Azure Arc namespace, you will actually see that there are a bunch of things that are running. So this maintains the connectivity back with the Azure Arc control plane. Now, once we have this running, it will immediately show up as an external cluster, Azure Arc enabled Kubernetes cluster inside the portal. Of course, I can also run the command prompt, command line from the terminal to actually see this in a CLI view. So we have 3 clusters that are registered with Arc. So pretty straightforward. To save time, I install the agent beforehand. Now the first step, we have gotten all the clusters to technically report into the Azure Arc environment. Now we have a pretty decent view of the inventory. We know where the clusters are running, and we know all of them are registered with Arc. But what else can we do? Well, the second thing, how do we push an application centrally into all the participating clusters? Well, for that, let's say we use a GitHub repo. This is a GitHub repo that I am actually using from the Azure Arc documentation. So this contains a bunch of directories, and every directory has some YAML files that are Kubernetes artifacts. For example, if you go to namespaces, there is a namespace called IT Ops. And similarly, there is a namespace called Team A and Team B. So within that, there is cluster apps, and we have our favorite Azure Vote application that is available here. If you actually inspect this, this is the entire deployment of Azure Vote application. And then there are namespaces, as we have seen. And then there are some policies that you may want to apply, ensure GitOps configuration for Kubernetes. So you can roll this out centrally. So how does this work? Well, once the clusters are registered, we can actually install the connected cluster and the cluster configuration mechanism. This is based on an open source project called Flux. So Flux uses GitOps based pull model to apply configuration from a GitHub repo. So let's run this in the context of the bare metal cluster. So before that, let me put this in watch. So let me make sure. Okay, so I will first switch to the context of bare metal, and then let's check the namespaces. So currently there are a few namespaces, and Azure Arc was created when we launched the agent. Now we are actually installing the GitOps agent based on Flux. So the moment I hit enter, oops, okay. So this is a live demo, so things are bound to change. So let me fix this. I need to run this in the context of bare metal. So our demo metal, and do I need to change anything else? Nope, that's it. So that is the cluster name, and let's run this. So now this is being applied, and very soon we'll see the cluster config namespace appearing in the cluster. So there we go. So cluster config shows up. Now if you inspect this further, so let's put this in watch, kubectl get all, and the namespace is cluster config. So there are no resources created yet, but very soon this will actually contain some artifacts that are responsible for pulling the resources from the GitHub repo. Now, as soon as this is done, because in the configuration we mentioned that it has to synchronize with the repository located at this URL, in a few minutes we'll actually see the namespaces that are mentioned, the voting application that we are pushing into the default namespace, and the IT Ops Team A and Team B namespaces showing up in the cluster. Now this will take a while, but I can actually switch to, let's say, GKE context. So when we actually look at the namespaces, we have the IT Ops, Team A and Team B. And you can actually look at the default namespace, and this is the Azure voting application. Now in some time the bare metal cluster will also assume exactly the same configuration. That is the beauty of GitOps enabled via Azure Arc. So very soon this will actually take place. Now the other thing is, in the context of GKE, for example, where we are already running Flux and the GitOps agent, what happens if we go ahead and delete one of the namespaces? Well, let's actually do that. So let's delete this namespace called IT Ops. So delete namespace IT Ops. Now this is actually deleted. It's an empty namespace. You can check out the repository and you'll notice there is nothing inside that. Now when you actually come back and watch this, in about 30 seconds, IT Ops namespace will show up. That's because the agent running under cluster config finds that this configuration has a drift. It has deviated from what is mentioned in the single source of truth, which is the GitHub repo, and it will basically reapply the configuration. That means the cluster will be back in the desired state of configuration in just a few minutes, in a few seconds, depending on what kind of an artifact you are pushing. Now, this will ensure that irrespective of which cluster, it automatically, whenever it deviates from the baseline configuration, the Azure Arc control plane along with Flux will monitor the changes and will automatically bring the cluster back into the desired configuration state. That is the advantage of running Kubernetes clusters via Azure Arc and using the GitOps workflow for managing the desired state. And you can also push the Azure policies that are actually available. Now that was a quick demo of Azure Arc enabled Kubernetes. Now the last one, which is still under preview, and I want to spend a minute explaining what this is all about. So as I mentioned earlier, once Kubernetes is reliably running in different environments, we can take advantage of that to run a very scalable, highly available, fault-tolerant workloads. And Microsoft has done exactly that with Azure Arc. So the moment you have a Kubernetes cluster registered with Azure Arc, you can run two managed services under Azure Data Services. One is Azure SQL and the other one is Postgres Hyperscale. Now you can launch them from the portal, manage the entire lifecycle from the portal and treat them like yet another instance of Azure SQL or Postgres. But mind you, they're not running within the context of Azure ARM, but they are actually orchestrated by Azure Arc, and they are running in a third-party cloud or in a very different environment, and you still get the same SLA, same uptime, and same billing and visibility, even though you are running these data services outside of Azure. And this enables a lot of new opportunities for customers, for partners, and for organizations. So this is a huge advantage and a key differentiator for Microsoft. None of the other hyperscale providers are able to bring critical managed services like RDBMS into the hybrid and multi-cloud environments. This is one of the very first offerings in the industry. So that is Azure Data Services. It's currently available in a private preview. You can go sign up and request for white labeling your Azure subscription. And if you have a genuine use case, it can get done in 24 hours. So go give it a try. So let me summarize what we have discussed so far. So Azure Arc does three things: organize and govern resources across environments, particularly for VMs. The second one is contain and control cluster sprawl by bringing all of them into the fold of Azure Arc and managing that seamlessly from a single unified view. Third thing is, with Kubernetes running through Azure Arc in different environments, you can run data services, managed data services that are provisioned, launched, and completely managed from Azure portal. So those three are the critical capabilities and benefits of using Azure Arc in hybrid and multi-cloud environments. So that brings us to the end of the session. Thanks again for attending this. Have a great conference ahead. If you want to reach out to me, that's my Twitter, Janikram M, and janikram.com is my website. Use the contact form to reach out to me with any questions. Thanks once again, and I wish you have a great conference. Stay safe, stay home, and make sure you are taking care of yourself. Thank you.